Hello and welcome to Science and Sleep, where the stories of the universe, Earth, and human history are told in the whispering voice of time. This is a small, peaceful corner on the internet where curiosity can freely drift like a feather in the air. Whether you are curled up in a warm blanket or just happen to stop by for a moment of tranquility, I am very glad that you are here today. Tonight, we will embark together on a slow yet magnificent journey, crossing hundreds of millions of years, witnessing 5 moments when the world nearly sank into oblivion. These are not just dark days, but heart stopping chapters where life stood on the edge and miracles existed by the thinnest of threads. If you want to travel the entire journey with me and not miss any other stories from the distant past, press subscribe and stay with me until the very end. Trust me, what you are about to hear will change the way you see this world. If you could travel back in time to the end of the Ordovician period, you would witness a world completely different from what you imagine. There were no lush green forests, no roaring dinosaurs, and absolutely no humans. Instead, it was a planet almost entirely submerged in water, shallow oceans stretching endlessly, bathed in light and warm like a summer blanket. Beneath those waters, life flourished in an unceasing symphony. Primitive corals formed the first reefs, trilobites silently crawled across the sand like ancient cleaning machines, and giant nautiloids drifted like living submarines, slowly hunting with their tentacles. It was a golden age of the seas, when evolution acted like a daring artist, experimenting with countless shapes and bizarre ways of life. But then, like a song abruptly stopping mid-chorus, that tranquility ended. A rapid sequence of climate changes, fast by geological standards, began to spread. The supercontinent Gondwana, slowly drifting toward the South Pole, inadvertently pushed the planet into a frigid whirl. As vast landmasses became covered in ice and snow, sunlight was strongly reflected, causing global temperatures to drop even further. This was the albedo effect, a ruthless feedback loop turning Earth into a gigantic mirror. At the same time, carbon dioxide concentrations decreased, possibly due to weathering processes or microbial activity, weakening the atmosphere's ability to retain heat. The oceans where life had flourished now began to shrink. Sea levels dropped rapidly as enormous volumes of water were locked in glaciers. Shallow seas, the nurseries of Ordovician biodiversity, disappeared meter by meter, exposing bare rock beneath. Organisms accustomed to stable environments were suddenly forced to adapt or die. With over 85% of species vanishing, this was one of the most severe mass extinctions in history. This tragedy did not occur in a single wave, but in two consecutive ones. First, the cold cut through every corner of the ocean. Slow-moving sessile organisms like corals and brachiopods suffered heavy losses. Then, as the ice melted and temperatures rose again, the seas surged back, bringing chemical changes and unusual nutrient flows. This may have created oxygen-poor regions, dead deserts on the ocean floor, where almost no life could survive. The return of warmth did not mean immediate revival, but rather a further blow to already weakened populations. The frightening part is that all of this happened over just a few 100,000 years, a fleeting moment compared to Earth's 4.5 billion year history, yet long enough for countless generations of organisms to struggle in despair. Trilobites that once dominated vanished en masse. Many corals and echinoderms collapsed. The once bustling marine world fell into heavy silence, leaving only the waves and rare surviving creatures. But the story did not end with loss. From the fragile remnants of life, evolution began to paint a new picture. The subsequent Silurian period witnessed the emergence of groups of organisms never seen before. Jawed fish, a major step opening a new era of predators, corals rebuilding reefs, mollusks and arthropods reclaiming territory. The oceans once again teemed with life, but a different life, stronger, better adapted, ready to face future challenges. Looking back, the late Ordovician mass extinction was not just a disaster, but a global reconstruction. It shows that even without giant asteroids or supervolcanoes, Earth could reshape its own face through slow yet profound changes. Climate, continents, and oceans, three seemingly stable factors, can turn the world around in a few geological blinks. It also leaves us with a simple but important lesson. Life on this planet is never guaranteed. Every ecosystem, no matter how prosperous, exists in a fragile balance. A small global change is enough to break the chain linking all living beings. And when that happens, the survivors are not always the strongest, but the quickest to adapt. When we imagine lost worlds, it is easy to picture noisy scenes, forests steaming, volcanoes erupting, or massive tsunamis. But at the end of the Ordovician, the true destroyer was ice, silent, persistent, and unstoppable. It did not strike within hours like a storm, but advanced step by step, each generation of organisms noticing their environment a little colder, the seas receding a little further, food becoming a little scarcer, until the entire world was no longer as it once was. And yet, it was precisely this silence that paved the way for a new chapter. When the ice melted, when the seas returned, waters that had once been depleted became the stage for evolution to continue its endless performance. This extinction reminds us that the end of one era is always the beginning of another. Earth, with all its harshness and creativity, remains the greatest storyteller, and the story of the Ordovician is just one chapter in a book that never closes. As the ice of the late Ordovician gradually melted, the oceans expanded once again, but they were no longer the old home of life. The sands and rocky reefs abandoned for millions of years under the ice now welcomed new pioneers. Nutrient flows from the melting ice created unprecedented biological blooms. But this time, the main actors on evolution's stage were no longer the trilobites that once dominated. A new era was gradually unfolding. In the gradually warming waters, schools of jawed fish began to flourish. They differed not only in their strong teeth and ability to tear prey, but also in agility and sophisticated hunting strategies. Whereas previously benthic organisms could live safely protected by hard shells, now nothing guaranteed absolute safety. Alongside them, primitive sharks, armed with stiff spines for defense, crept into every corner of the ocean, becoming the new apex predators. The emergence of jawed fish was a major turning point, not only because they were more effective predators, but also because they forced every other organism to change. Corals and mollusks began developing more complex defensive structures. Some species adopted a hidden lifestyle, burrowing into mud or hiding in crevices. Others evolved faster reproductive rates to compensate for predation losses. The biological arms race had begun. On the seafloor, new forests of coral sprang up, forming a vibrant maze. Echinoderms, such as starfish and sea urchins, became more numerous, slowly sweeping through algae and organic debris. Among these reefs, primitive arthropods, distant ancestors of today's shrimp and crabs, lurked like tiny predators, striking suddenly at small prey. This was a young ecosystem, but full of life, no less fierce. What was remarkable about this period was that biodiversity not only recovered, but exceeded pre-disaster levels. The extinction had cleared the slate, leaving enormous ecological gaps. And evolution, like a painter with a blank canvas, did not miss the opportunity to fill it with new designs. New groups of organisms quickly occupied the positions left vacant by predecessors, but with better adaptability, greater resilience to environmental fluctuations. However, the lessons from the late Ordovician still simmered like a collective memory of life. Many species developed broader temperature tolerance, some adapted to low oxygen conditions, and many migrated seasonally or according to environmental cues. The post-extinction world was no longer just for the strong, but for the flexible and patient. If you dive deep into the Silurian seas, you would see a completely new picture. Light filtering through blue waters, painting fan-shaped and spherical corals, schools of jawed fish swimming together, their bodies reflecting silver glimmers, and in deeper layers, primitive sharks silently cutting through the water, their silhouettes faint in the sparkling light. Everything seemed peaceful, but this balance was only temporary. For Earth's history never stands still. Even as the oceans teemed with new life, tectonic plates continued to shift, and global chemical cycles quietly changed. And somewhere on the planet, the seeds of another upheaval had begun to sprout. None of the creatures under the sea knew that, tens of millions of years later, another crisis would sweep through, wiping out many species that had just reclaimed life. But at this moment, in the Silurian, the world was reviving. This was a rare moment in history when life not only recovered but also surged forward, experimenting with forms, strategies, and lifestyles never seen before. A silent biological revolution beginning from the seafloor would continue to shape every subsequent era, and this was only a part of a much longer story. The late Ordovician mass extinction was the opening chapter of the series of 5 times Earth nearly lost all life. The next time, more dramatic, more violent, would not come from ice, but from a fury erupting from deep within the planet. After millions of years of explosion and flourishing, the Devonian, famously known as the Age of Fish, gradually shifted into a period of harsh challenges. If you could travel to the end of this period, the picture you would see would no longer be filled solely with the vibrant green of life. Somewhere beneath the seemingly calm waters, silent but intense changes were accumulating. The first cracks in the ecosystem began to appear, and they would persist for tens of millions of years, creating one of the most complex extinction sequences in Earth's history. What was striking is that this disaster did not occur like a sudden asteroid impact or an immediate, devastating volcanic eruption. Instead, it resembled a prolonged illness, recurring many times. Each time life struggled to recover, a new blow struck. Paleontologists call these extinction pulses, successive waves of biodiversity decline interspersed with brief periods of recovery. The cause? To this day, scientists have not reached complete agreement, but much evidence points to an unexpected culprit: plants themselves. As primitive forests expanded across the continents, tree roots penetrated deep into soil and rock, accelerating chemical weathering. This process drew CO2 from the atmosphere, causing global temperatures to drop. In this context, the climate became cooler and more volatile, a severe challenge for organisms accustomed to stable environments. But the story did not end there. The presence of forests also altered nutrient flows into the oceans. When heavy rains fell, mineral-rich soils were washed into rivers and then poured en masse into the sea. This excess of nutrients ignited massive coastal algal blooms. At first, the seas seemed carpeted in shimmering green, but as the algae died and decomposed, they consumed enormous amounts of oxygen, turning once thriving waters into dead zones, areas where almost no life could survive. For Devonian coral reefs, this was a critical blow. The giant underwater cities, once the centers of marine life, began to collapse. Organisms dependent on the reefs, from small fish to complex invertebrates, vanished as well. After this event, it took over 100 million years for Earth to witness the resurgence of coral reefs of comparable scale. Fish, the stars of the Devonian, suffered the same fate. Many giant armored fish disappeared entirely. Predators that once dominated the ocean, such as Dunkleosteus, with jaws capable of crushing the shells of imaginary turtles, went extinct. Even the lobe-finned fish, ancestors of few tetrapods, suffered heavy losses. This was particularly significant as these groups were on the threshold of stepping onto land. Their loss slowed evolutionary progress, delaying the emergence of primitive amphibians. Amid this chaotic picture, there were still survivors. Some ray-finned fish and primitive sharks continued to exist, even in oxygen-poor, less biodiverse seas. Some invertebrates found ways to adapt to murky, resource-poor waters. On land, forests continued to expand, even stronger after each marine biodiversity decline. This reveals an ironic truth. Sometimes the prosperity of one group of organisms is the cause of a crisis for another. The expansion of plants not only changed the landscape, but also reshaped climate, ocean chemistry, and the rhythms of the entire biosphere. In retrospect, the late Devonian resembles a severe test that the planet imposed on life. Those unable to adapt quickly enough vanished. Survivors carried new traits, sometimes unexpected, that allowed them to open new eras. It was during this period that the foundations for future ecosystems were laid, albeit at the cost of countless species. And perhaps this is why evolutionary history contains a strange paradox. Mass extinctions are both tragedies and opportunities. When one chapter closes, it frees space for new stories to be written. The Devonian did not end with a single explosion, but with the prolonged rumble of a world in transformation, slow, painful, but irreversible. If you listen carefully, you can imagine the sound: the collapse of coral reefs, rivers washing red soil into the sea, the weak flapping of fish fins in suffocating waters. Yet amid these dying sounds, a persistent pulse echoes, the heartbeat of life, which will continue to adapt, renew, and rise once more from its own ashes. If the Devonian was a lingering illness lasting millions of years, then the end of the Cretaceous was like a sudden punch from the cosmos, swift, precise, and devastating, leaving no ecosystem any time to react. At that time, around 66 million years ago, Earth was a lush green paradise where giant dinosaurs dominated the land. Flocks of pterosaurs soared like kites in the sky, and beneath the seas, brilliantly colored creatures frolicked among coral reefs. But in just a few hours, that order was overturned forever. Imagine a typical morning in what is now the Yucatan Peninsula. The sun was high, a gentle breeze rustled through dense forests where herds of herbivorous dinosaurs grazed leisurely. No one knew that hundreds of thousands of kilometers away, a colossal rock, larger than Mount Everest, was hurtling toward Earth at tens of kilometers per second. It did not care about the season, nor whether you were living happily or in distress. The universe had no intention, yet it did not need intention to cause disaster. The impact occurred in the blink of an eye. A blinding flash, brighter than any lightning streak, swept across the sky, followed by an explosion echoing across the continent. A catastrophic shockwave flattened everything within hundreds of kilometers. Temperatures soared high enough to incinerate exposed life. But this was only the prelude. The asteroid had drilled a crater over 30 kilometers deep, releasing energy equivalent to billions of atomic bombs. Countless fragments were hurled into the atmosphere, then fell back at terrifying speeds, their friction with the air turning the entire sky into a massive furnace. Many species were roasted alive on the ground, and as rock dust, ash, and sulfurous gases filled the atmosphere, sunlight was blocked. An impact winter began. Plants reliant on light for photosynthesis withered en masse. Food chains collapsed in cascading reactions. Herbivores starved, followed by carnivores. Global temperatures plummeted while acid rain from sulfurous gases devastated both freshwater and marine environments. Within less than a century, 75% of all species on Earth vanished, including all non-avian dinosaurs, most marine reptiles, and many important plants and plankton species. But the story did not end with destruction. In the darkness and cold, smaller organisms, less dependent on light, began to find opportunities. Some small birds survived by eating seeds, a food source that could endure months without sunlight. Mammals, modest creatures that had hidden in the shadows throughout the reign of the dinosaurs, became the inheritors of an empty world. They quickly diversified, occupying vacant ecological niches, initiating a new era that would ultimately lead to us. Interestingly, this impact was not just an ending, but also a beginning. Without it, humans might never have appeared. If dinosaurs had still ruled, would a small, two-legged, scaleless, intelligent, yet fragile creature like a human have had any chance? It is hard to say, but Earth's history has always been a series of disasters paving the way for unprecedented events. This event also reminds us of the fragility of life. A world seemingly stable can be completely transformed by an extraterrestrial event. We often think of threats within our visible range, storms, earthquakes, volcanoes, but the Chicxulub impact at the end of the Cretaceous shows that the killer sometimes comes from farther away, more silently and without warning. Looking back over the entire history, from the Devonian with forests inadvertently choking the oceans to the Chicxulub impact ending the age of dinosaurs, one thing becomes clear. Earth does not stand still. Life does not stand still. Every species, large or small, strong or fragile, is part of this vast evolutionary game. And that game has no ending, only new rounds, each rewritten from the ruins of the previous one. So, what do we learn? That even when faced with events seemingly ending everything, there is still renewal. That the small, quick to adapt, and opportunity seeking species are the true winners. And that if humanity wants to endure into the future, we must remember that we are only one chapter in a much longer story, a story the universe authors inadvertently, yet with immense power. If you want to continue this journey, from ancient forests inadvertently causing deaths in the seas to a cosmic rock wiping out an entire era, make sure you have subscribed to the channel and turned on notifications. For this is only the beginning of the mysteries and lessons that Earth's history of extinction has to offer. Each subsequent story will be stranger, more intense, and sometimes more thought-provoking than the last. If the Devonian was a slow symphony, where lobe-finned fishes and the first amphibians practiced each note along rivers and swamps, then the Permian was a pounding drum, reverberating across the planet. Around 252 million years ago, Earth stood on the brink of an unprecedented event, a catastrophic mass extinction so immense that all life, once proud of its existence, could only gaze at each other in stunned silence. The supercontinent Pangaea, vast and magnificent, stretched from the North Pole to the South Pole, turning half of the interior into scorching deserts and seasonally frozen lands where water existed only in small rivers and shallow swamps. Creatures accustomed to stability now had to struggle against a harsh environment like never before. Fluctuating temperatures, erratic rainfall, and ecosystems fragmented into isolated pockets. Everything seemed to signal that a brutal purge was imminent, yet no one could imagine the true scale. Then, from the distant east in the land now called Siberia, the ground began to shake. Massive, dense, and continuous lava columns erupted into the sky, spreading over millions of square kilometers, turning the land into a flowing sea of fire. But the lava flows were only the most visible part. The more terrifying force was the gases. Carbon dioxide, sulfur dioxide, methane, compounds rising into the atmosphere, altering the world beyond repair. This was no ordinary warming, but a global fever lasting thousands of years. Oceans heated, became acidic, and lost oxygen. Marine species, once dominant across all water layers, faced mass mortality. Imagine the once sparkling coral reefs now turned gray, populations of large fish vanishing in just a few generations. Muscular, aggressive creatures built to hunt in stable environments could no longer keep up with the constant changes in water and air. Lobe-finned fishes, once pioneers along the shore, were now tested on an entirely different level. Survival was no longer just about swimming or breathing, but enduring a planet blazing with fire and suffocating heat. Yet the miracle continued, in the way Earth has always preferred. The adaptable, flexible, and small still found a path. Small vertebrates, invertebrates, insects, mosses, and some resilient plants took root in surviving areas. They became hidden seeds of life, waiting in the shadows for an opportunity. These seemingly tiny and weak creatures became the foundation for the future. The Permian mass extinction was not merely a biological flood. It was a symphony of cause and effect, where volcanoes, climate, ocean chemistry, and natural cycles resonated to create global devastation. Each lava layer covering the land, each sulfur gas drifting into the atmosphere, each drought, flood, or prolonged cold spell was a note in this wordless tragedy. Species unable to adapt, too large to hide, or incapable of changing their diet were eliminated. Amidst this destruction, the world seemed cleared with an iron axe. 90% of marine species vanished. 70% of terrestrial species were erased. Coral reefs collapsed, swamps dried, forests fell silent. The once dominant species remained only as fossils, reminders that strength or beauty does not guarantee survival. Yet from this vast ecological void, new opportunities emerged. Remarkably, life always finds a way. Small, diverse, and flexible species, small vertebrates, plankton, resilient insects, began reclaiming the world. Gradually, ecosystems restarted from seemingly fragile seeds. Moss grew on rocks, ray-finned fishes swam in low-oxygen waters, amphibians took tentative steps along pond edges, and thriving vascular plants once again covered the land. The shock of the Permian serves as a reminder of the power of adaptability and flexibility. It shows that within every disaster, opportunity exists. Within every ecological void, small creatures can become the foundation for new diversity. It also demonstrates that evolution is not a linear accumulation. It is a complex game of loss, opportunity, and innovation. And as if by miracle, from the small survivors of the Permian mass extinction, the world began to rebuild. Some groups of vertebrates, once rooted along the water's edge, now diversified, flourished, and were ready for the great strides of the next eras, Triassic, Jurassic, and Cretaceous. Lobe-finned fishes, the first amphibians, and flexible species remained, silently laying the groundwork for a new ecosystem, a future no dominant species could have predicted. In the broader view, the Permian mass extinction is not merely a tragic ending. It is a reminder that Earth, though fierce and relentless, always grants opportunities to creatures patient, adaptable, and resilient enough. From the fragments and ashes, life rises. From global collapse, renewal emerges. And from that darkness, all future species, from birds and mammals to humans, would be born, continuing the chain of evolutionary memory that the Permian mass extinction etched in fire, ash, and life. If you thought disaster was merely a gradual rise in temperature, the Permian proves that nature can suddenly become violently catastrophic. This was not a hotter than usual summer. It was a greenhouse gas explosion, a chain of events in which the planet heated itself from within. Global average temperatures surged, oceans warmed by several degrees, making surface waters scalding hot, while the previously cool, oxygen rich, deeper layers became stagnant and hypoxic. These were dead zones, where nearly all complex life could not survive. Sulfur dioxide, a volcanic byproduct, combined with water vapor to form acid rain, devastating forests, washing nutrients from the soil, and poisoning freshwater ecosystems. But the calamity did not stop there. As the climate heated, catastrophic feedback loops were triggered. Methane, stored in oceanic sediments, a greenhouse gas far more potent than carbon dioxide, began to release. Once methane was emitted, it accelerated warming, creating an uncontrollable chain reaction. The Earth cooked itself from the inside out, and all life suffered the consequences. The oceans, once the cradle of life, became suffocating. Oxygen levels plummeted, and vast stretches of seas turned into dead zones, devoid of oxygen. Coral reefs collapsed, and shelled organisms that had dominated for hundreds of millions of years nearly vanished entirely. Trilobites, creatures that had survived many previous extinctions, also reached their end. Even the hardiest organisms could not escape. Amid the hostility of the seas, certain specialized bacteria thrived. They flourished in oxygen-depleted environments, producing hydrogen sulfide, a toxic gas with the stench of rotten eggs. When accumulated in sufficient quantities, hydrogen sulfide could escape into the atmosphere, destroying the ozone layer and allowing ultraviolet rays to reach the surface, putting remaining life in peril. The picture was grim. Suffocating oceans, scorching lands, poisoned air, and UV radiation striking the ground. On land, the scene was equally tragic. Forests across Pangaea died off, rivers were clogged with plant debris, and amphibians and reptiles unable to regulate their body temperature suffered heavy losses. Simple animal groups vanished from the fossil record. This was not a sudden strike, but a prolonged chain of extinctions lasting tens, perhaps hundreds of thousands of years, with ups and downs, fleeting moments of hope, but ultimately total devastation. Yet, miraculously, some life persisted. Organisms clinging to isolated refuges, or those with flexible biology, survived the dark period. On land, small but resilient creatures like Lystrosaurus, a pig-sized tusked animal, wandered the scorched terrain, defying all odds. They were neither beautiful nor elegant, but steadfast and enduring. Resilience became the only weapon in this shattered world. The Permian mass extinction did not merely erase life, it reshaped the evolutionary structure of the planet. Vast ecological gaps appeared. Small vertebrates, the primitive ancestors of mammals, began to diversify, occupying roles vacated by previously dominant species. Arosaurs, precursors to dinosaurs, birds, and crocodiles, found opportunities to survive and expand. The biosphere could be devastated, but not defeated. The Siberian volcanic eruptions, covering more than 7 million km², were the main driver of this catastrophe. Lava flows, sometimes gentle, sometimes violently explosive, spewed ash and gases into the atmosphere, altering global climate. Carbon dioxide, released from magma and melted coal layers, surged, trapping heat in the atmosphere and driving the greenhouse effect. Global temperatures are estimated to have risen by up to 8 degrees Celsius, enough to disrupt all living systems. Oceans warmed, became oxygen poor, generating dead zones and nurturing toxic bacteria. The complex feedback chain, volcanoes, climate change, low oxygen, toxic bacteria, ozone destruction, increased UV radiation, led to a double disaster. Each step of nature pushed living organisms closer to the brink. The remaining creatures were like sailors patching a sinking ship while constantly battling storms. And though most failed, a small, hardy group persevered. Remarkably, from that smoldering wreckage, life not only revived, but also innovated new forms. Small, flexible, fast-adapting lineages became the foundation of the Triassic, ushering in a new era of vertebrates, including the ancestors of birds, mammals, and modern reptiles. This proves that Earth never fears an ending. It merely turns the page, using ruin and crisis as a springboard for renewal. The Permian is a vivid lesson in the interconnectedness of Earth systems, the deadly power of climate feedback loops, and the resilience of life. It reminds us that nature is both harsh and tenacious, and that even in the darkest hours, seeds of life quietly await their chance to rebound, stronger, stranger, and bolder.